All right, welcome back. So today we are going to be reviewing how to find slope when we are given a graph. There are three different tasks that we are going to be completing in this video that go along directly with your practice problems. So without further ado, let's begin. The first set of problems is going to ask you, is the slope of each line positive or negative? And how do you know? So let's just remember how we read slope. When we are looking at a graph, we read it going from left to right. Just like a book, right? When we are reading your traditional book, you're reading it from the left to the right. Well, we're going to be doing that exact same method when we're looking at lines. We want to see if we're looking from the left, we're starting on the left-hand side, and we're reading it to the right. Is that line going up or is it going down? Is it increasing or is it decreasing? If it's increasing, it's going to show a positive value. If it's decreasing, it's going to show a negative value, because if we're going up, we're going positive in the y direction. If we're going down, we're going negative in the y direction. So as we go up, it's going to be a positive slope. As we go down, it's going to be a negative slope. So if we look at problem number 1, we're starting up here on the left, and we're ending way down here on the right-hand side. So if I were to look, let's say I drew just a quick dotted line, and you don't have to do this, but it's a good visual help here. If I'm starting from that point on the dotted line, when I ended all the way down here. Is that end point above or below the dotted line? Yeah, it's below the line. So this is going to be a negative slope. We're going to say that this line has a negative slope because we are decreasing. And that's how we know, because we're decreasing. We're reading it from left to right. We are decreasing. Well, let's look over at problem number 2. We look all the way to the left, starting over here, and look all the way to the right, and we're ending up there. Again, just as a visual tool here, let's say we're looking at this starting line. Well, is my end point, again, which is up here, is that above or below that dotted line? But it's above, right? This blue line is going up. As we read it from left to right, it's going up. So this is going to be a positive slope. And it's because we are increasing. Since we are rising up, we have a positive slope. If we're going down, it's going to be a negative slope. Number 1 is negative because we're going down, we're decreasing. And number 2 is positive because we are going up, we are increasing. Awesome. Now we have some more problems here. Problem number 21 and 22. And the directions say to find the slope of each line. So before, we were just identifying positive and negative slope, but now we want to calculate the slope. We want to figure out, again, our slope is equal to the change in our y values over the change in our x values. We use the words rise and run. It's our rise over our run. So we want to figure out how much we go up or down compared to how much we go to the right. And we always want to think about going to the right. Just like we're reading a book, we read it from left to right. So we're going to the right. Sure, there might be some instances where we can go left, but we always want to read to the right because we know going in the right in the x-axis is a positive value. So we want to stay as positive as possible. So let's try to calculate the slope of each line. Let's look at problem number 21. Again, we know the slope is equal to our rise over our run. We also call it the change in y, and that delta sign means change, over our change in x. So if we're starting at the point on the left and we're ending at the point on the right, let's count how much we go up or down. Where we go 1, 2, 3, 4. We went down 4. So we have a negative 4. All right, well, let us now calculate how much we go to the right. Well, we start where we ended. We're going to start at that area. And now we're going to go to the right, where we go 1, 2, 3, and 4. And we go to the right 4. We have our value of negative 4 over 4, and we always ask ourselves, can we simplify? Well, yeah, we can. Negative 4 divided by positive 4 is equal to negative 1. So our final answer here is going to be negative 1. The slope is going to be negative 1. Beautiful. And that should make sense if it's a negative 1, because if we look at the line, well, it's decreasing. It's going down. So we should have that negative sign because it is going down. So we have our negative sign there to show that. Awesome. Here we go. Let's talk about problem number 22, problem T swizzle. Here we go. So we have our rise over our run. We also call that the change in y over the change in x. So we want to calculate, oh, that should not be green. Let's go back. Come on, here we go. There we go. We want to see how much we go up or down compared to how much we go to the right. So for this time, we're given 2 coordinate points on the line. So it's going to be even easier for us to do it. So we're going to start at the point to the left. We're going to count up or down. Well, we actually go up. We go up 1 and 2. We go up 2. All right, so now we're off the line. We want to get back on the line. So we're going to start at the point we ended. We're going to pivot. We're going to turn. Let's see how many spots we need to go to get back on the line. We go 1, 2. So we went 2 to the right. So we have 2 divided by 2. We ask ourselves, well, can we simplify that? Yeah, certainly. Forgot to include m. Whoops. So we have our slope is equal to positive 1. And we should have a positive value because if we look at our line, well, it's going up. So we have a positive value. Awesome, awesome, great job. Here we go, 2 more problems. So now, the only difference about these problems is that we aren't given those perfect coordinate points. In the previous problems, if I go back, we're given those 2 coordinate points on the line. We're given 2 points on the line. But now we just have to do a little bit more work, nothing too challenging, and we want to find those perfect intersections with our coordinate plane. Sometimes you're going to find 2 points. Sometimes you are going to find 5, maybe 6, maybe even 8. Who knows? So long as you find 2 points, you're going to be completely okay when it comes to finding the slope. The trick is to look at your coordinate plane, the grid, and see where it perfectly intersects with your line. Now, we need a perfect intersection here, not a partial. We don't want it halfway on a line. We want it perfectly in that intersecting, okay? So if we're looking at problem 41, we want to look and find perfect intersections. Well, I see I have a perfect intersection right here. I also see I have a perfect intersection right here. Now, you might see other points, and that's totally okay, so long as we end up with the same value. So long as we end up with the same value, we simplify those fractions, we're going to show the slope of that line. So now we go back to what we did before. Now that we have those 2 points, we want to find the change in y over the change in x. So let's calculate. Well, if we're starting at the point on the left, we go up 1, 2, 3. We go up 3 units. So that's a positive in the y direction. Now we want to go to the right to get back on that line. We go 1, 2, 3. So we have 3 divided by 3, which is equal to 1. So our slope is going to have a value of 1. Now, you may have found different points than I did, and that's totally fine. But if you simplified your fractions and you set it up correctly, you're still going to get a slope value of positive 1. So we always want to simplify whenever possible. All right, let's go on to problem number 42. My favorite number, 42. Love it. So we, again, want to find the change in y over the change in x. But this time, we don't know those coordinate points, just like 41. We don't know those coordinate points. We need to find them. So we're going to have to look for perfect intersections. I see a perfect intersection right there. And I continue to move down, and I see a perfect intersection right there. Now be careful. Sometimes it looks perfect, but you got to really analyze it and make sure it's a perfect intersection with that coordinate plane. So now we want to calculate how much we go up or down compared to how much we go to the right. If we're looking at the point on the left, we are going down 2, 3, 4, 5, 6, and 7. We go down 7. So we have a negative 7 in our numerator. And now we got to get back on the line. We go 1, 2, and 3. So we go positive 3. So our value is going to be negative 7 over 3. We ask ourselves, can we simplify? And we cannot. Therefore, we get negative 7 over 3. Leave it as an improper fraction. Do not change it to a mixed number because we are soon going to be using the slope in helping us graph the line. So right now we're looking at lines to find the slope. Soon we're going to be using slope to graph the lines. We always want to make sure that we have an improper fraction. All right, folks, great job. Please work on the rest of the worksheet, and I'll talk to you soon. Bye.